Okay, solenoid make up of several turns, right? And the turns form a cylinder. Not like a loop very thin only, but this one got a significant length, right? So the field is just like a bar magnet, except bar magnet, it doesn't go through what coil, the field goes through the coil. Okay, same like bar magnet. Sorry, press on the internet. What is happening? Okay, now we will hear. Can you all see? Cannot see, let me know. Right, same thing. Right, inside there is uniform because all of them are parallel. They are squeezed all together, cannot escape anywhere. But when it comes out, it have to spread out. So it's spread out. Right? Say they are not occupying the same area anymore, occupying a bigger area. So it becomes weaker and weaker as you go further away. Right? Center part is uniform. Right? Inside there, the lines are parallel. That's why we say uniform. As it goes out, it spread out into a bigger area. So outside here, it becomes non-uniform. As you go further, it becomes weaker and weaker because it spread out further and further away. Yeah, I keep on pressing the wrong button. That's why it's coming, disturbing all this. Sorry. Right, uniform inside, non-uniform outside. Stronger at the center and decreases to half the value at the entrance there or exit there. Right? Because it can spread out, occupy more space. Right? Bar magnet, nothing, no lines of, no magnetic field lines there. Whereas coil, you got there, right in the center there. Okay, how do we get direction? Right? When we say long solenoid, we compare the diameter, right? This length there and this diameter. Right? If that length is longer than the diameter, much longer, then we say it's a long solenoid. Right? And the field is uniform at the center here, somewhere around here is uniform. As it go outwards, it become non-uniform. Right? So long means the length, right? That's the length. It's very much greater than the diameter of the coil. There's a diameter and there's a length. Okay? Comparison only. How we mean long.
那上课是吗？说要承认补课，我不去京都吃。
Okay, so magnetic flux density in the
它不
coil.
是有一处吗？也是哎呀妈，什么玩意吗？也是
You look
哎呀
like
妈，
this
什么
formula.
玩意吗？我怕以为是错。这个不讲你啊，我会
U
有这
naught
个。
permittivity of free space. N is number of turns per unit length. I is the current. Right? Remember, not number of turns per unit length. That means number of turns divided by the length of the solenoid. I is the current. So you can see more turn, more field. More current, more field. Right? Same. Because the current is the one that contributes to the field. Each coil contributes to the field. More turns, more field. Right? So in general, the strength or the magnetic field strength or magnetic flux density can be increased by increasing the current, increasing the number of turns. Right? Each turn will give one current and will give the field. More turns, give more field, you add up the field. And you can also increase it by putting a soft iron inside there. You change the mu naught. Right? You increase the mu naught. So we can increase the magnetic field. Right? That's what we do in electromagnet, but by putting a ferromagnetic material. Ferromagnetic material can be iron, can be steel, copper, nickel. So by putting ferromagnetic material, we increase the magnetic field greatly. Right? That's your roughly what you all study in your lower form. Right? The electromagnet, a simple electromagnet. Right? There is a stronger electromagnet. Right? That we can use to separate the metallic part from the non-metallic part. Okay, same thing. Yeah, you should be able to determine the polarity by now. Use your right hand curl rule. Sorry, right hand grip rule, not curl rule. Grip rule. Right hand grip rule. Right? You grip it. Your fingers will follow the direction of the current, and then your thumb will show you there is north, the top there. Okay, fingers show the direction of current, and the thumb show you where is the north, right? Or the line of force. That force is pointing north, upwards there. Okay, I think this is the simplest one now. Does not mean you cannot use this one. Look at the end there, and look at the field. If it is anti-clockwise, then it's north. Right? If you look here, right, if the current is flowing clockwise. If you look at the end there, the current is flowing clockwise in the loop. Then it's a south pole. Right? That's the alternative way. So whichever you prefer, you can use it. Nothing wrong. Both will give the same answer. Right? When I was in Form 3, I was confused. I can't understand how to read how to see the clockwise or anti-clockwise. But the grip rule is easier. Right hand grip rule.
What
Okay.
is this?
What is what?
I don't understand.
We are trying to predict the polarity of the pole there. That's all. If you have a battery, you have a solenoid there, we are trying to determine which is north pole, which is south pole, that's all. So I'm give you an alternative way of determining the north and south pole. If you look at the end there, if you see the current as going clockwise, then it's the south pole. That's the picture there. If you look at this end, it is anti-clockwise, right? Going that way, like that. Then it's a north pole. Yeah. Same. Either way, you can choose to use this way. To me, I feel this is easier. The fingers show the direction of the current. Yeah, you just grip the right direction, and then that shows you where the north of the north is here. Okay. Okay now, Su Wei.
Okay, sir.
Right? So just imagine right? Solenoid is just like a bundle of stick like that. Where you bind it, the center there, it will be all straight. By the end there, there's nothing to restrain it already, so the stick tend to spread out. So same, magnetic field, the same thing. Right? Where you constrain it inside the solenoid, it's all uniform. But as it comes out, it becomes non-uniform. Okay, where's the north here? Anyone? Where's the north? Yep, where's the north? Suiji, where's the north?
Left side.
Okay, good. This one, no? The finger I already show you already. Answer is just there. There's your south. Okay. Okay, how many number of turns here? What is your N here? Number per unit length. Anyone? Anyone?
16.
So you count 0,
L
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 divided by L, that's your N. Yeah, per meter. That's how you find your L is the length of the solenoid from one end to the other end. Okay. Why is this disturbing? Sorry. Just correct the mistake a little bit. Okay. Okay, that's how the graph look like. Right? Uniform. And as it leaves, the largest value is BC lah, center there lah. Right? C is our center. And as it goes, come out, decrease to half, then it starts continue to decrease further and further, become smaller and smaller. But usually we are more interested in uniform field lah. So we are interested in the center here only, right? Not outside. So you must know how to draw the few lines, right? Know how to draw roughly the graph, how to sketch that. Okay, so we have more or less completed. Let me just summarize for you. Ferromagnetic material can be iron, can be steel, can be cobalt, can be nickel. What's the purpose? Concentrate. Concentrate and pull them all together, the field line. Concentrate. So it increase greatly the magnetic field strength. Increase your B. Right? We use that electromagnet. Where you use electromagnet, electric motor. Right? Where you separate the garbage, right? Metal from non-metallic part. Right? Recycle the metal. Right? If it's ferromagnetic, it can be magnetized. Steel becomes permanent magnet. Iron becomes temporary magnet. That means it loses magnetism when the usage of the current. The current must be on, then it becomes a magnet. The current is off, becomes non-magnetic. Only steel becomes permanent magnet. Right? So we give it a special name, iron, we call it soft magnetic material. Non-ferromagnetic, example, copper, aluminum, no, it must not. It doesn't magnetize. Cannot be magnetized at all in the magnetic field. But you pass the current into the coil, then it can become magnetized. Right? Because it's the current flowing in the coil that produces a magnet. But it doesn't become magnetized at all. Okay? Okay, next part, we are going to look at magnetic force between wires. Oh, I think we better leave it for tomorrow. We'll stop here. Next application is we are going to look at the force between two current carrying conductor, whether the current is the same direction, opposite direction, and this is roughly the formula. So I will stop here. Those who got question, want to stay back and ask question, can stay back. Okay, you want to go, can go now. Have a good rest. See you all tomorrow.
Thank you, sir.
Okay, bye. Yeah.
Thank you, sir.
Anyone got question? Got question, can stay back and ask, no problem with me. We still got some time.
So tomorrow the test is all magnetic field.
No, tomorrow the test is on electric field. Just a few questions, about between 15 to 20 questions.
Is AS or A2 one?
Multiple choice A2 lah. Of course, of course, there's you AS. AS you should all be finished already. You should know your AS stuff already. Now we are trying to push you all to study your A2.
Bye-bye. Thank you, sir.
Have to start to push you all already. So you start revision already, not leave it for until you all go back to college. Okay, you'll be all stressed out with all your A2 teachers trying to finish their syllabus.
Okay, thank you, sir.
Okay, bye-bye.
Chapter 17,
Yep. A2.
until chapter.
A2 lah, the whole topic lah, A2.
Wow, a lot
Where got a lot? Electric field, a small chapter only. You relax too much like you.
Not chapter 17, 18, 19
No, one topic only. Electric
Oh,
field.
chapter
Electric
chapter
field only.
17.
A2 electric field, very short topic only.
Oh, electric field, not magnetic field.
No, magnetic field, electric field only.
Okay. Thank you, sir.
Okay, bye.
Bye-bye.